O has a 2. 2 comes down, 4 comes down. So when you write Ni2O4, what are you supposed to do that 2 and that 4? Reduce.
What?
It's just like in math class. Okay? Never. Math class. What would you do if you had 2 over 4? What would you do if you had 2 over 4? You get 1/2, right? So this and this reduce by 2. So this is a 1. This is a 2. So you get NiO2.
Are we going to have to do this on a quiz?
I don't know. I don't remember which one I picked. I have like 5 of these. I just picked one out of the notebook.
Is Ni2O4 the right answer? Will you count that right, or are you only going to count NiO2?
I will only give you full credit for NiO2, but it's the only thing I will give partial credit for. If you forget to reduce, you get half. All right, so number 5, manganese 5 cyanide. So manganese has a Roman number of 5, so the oxidation number is a 5. Cyanide is Cn with a -1. What do you do for every polyatomic ion? Put in parentheses. So you get a 5 and a 1, and that's what you get. All right, if you don't have parentheses, it's wrong, okay? And of course, I would not have the 1 there. Now, everybody left the parentheses on, correct? If you took the parentheses off, it's wrong. Everybody good with that?
Yes.
Okay, so barium bromide. Barium is a 2. Bromide is a what?
-1.
So 2 comes down, 1 comes down, and you have Ba, Br with a 2. Questions about the opening? Feel okay about them? Okay, I got nodding heads out there. Anybody else have a question? Yeah.
How do you know which oxidation number you use?
Barium or bromine? Bromine. Because it's last, the oxidation number has to be what sign if it's last? Positive or negative? Negative. And the only one that's listed by bromine that's negative is which one? That's why it's -1. Okay? All right. Let's see. Oh, I actually wrote down the answers again. Go me. All right. Let's get rid of this. I get rid of that cobweb I just got off the board. No. All right, keep Franco's crap. All right, there are the first 10. Yep, that's the homework answers. Questions? You getting them right?
Yeah, just forget to reduce or whatever.
But if you forget to reduce, that'll cost you half. Okay, that's the only thing I give partial credit on. Because your formula is not wrong. It's just not in lowest terms.
And you won't count on it like we put parentheses when we didn't like have to.
Right. So like this I would take, or that I would take. I'd take either one. Yes, ma'am.
So you only reduce when the two numbers are like
The same or reducible. Yes.
outside of each other.
Yes. Correct. And like number 9, if you don't have the parentheses, that one would be wrong. It has to have the parentheses.
So for, 7, even if there's just 2, could reduce, if there was all of them could reduce.
All right, since it's a 2, and a 7, can all 3 of them be reduced by the same number? You can't reduce there though.
Even if they were reduced since it's not outside of the parentheses?
No. Generally speaking, if you get a polyatomic ion, like, which one did we just use? Oxalate? And the polyatomic ion says C2O4, don't reduce the polyatomic ion. Okay, if you copy the polyatomic ion off the sheet, that's its formula. Don't change it. The only thing you would reduce is something that you crisscrossed. Okay, don't change a formula that I give you or that you get off the sheet. All right, can I erase it? Those of you are just writing down answers because you didn't do it. I'm not checking it, so you don't have to have them. All right, and here are 11 to 20. Now, 21 to 25, if you didn't get those in a minute when I slide it over some, don't worry about those. That goes with today's lesson. I just wanted you to give those a shot and see what you could do. If you named it carbon dioxide and sulfur dioxide, that's old system naming. You're going to have to learn how to name it with a Roman number. Okay? Well, I guess you don't have to have the question here. I can slide that over so that those of you who check faster can see both answers. All right, we had a chance to check them all. Questions, comments, concerns, something you want to ask. If you didn't get 21 to 25, don't worry about that. That's today. But in 11 to 20, if you didn't get and have a question you want to ask it, that one you can talk about. Anybody struggling with 11 to 20, need to ask. So we feel pretty good about 1 through 20. Yeah? Okay, let's do the quiz. You should do well then. And I should not be suicidal after grading them.
Oh.
Sometimes after I grade a quiz, I feel that way. Because I feel like I didn't teach much. I might as well have just stayed home. Left y'all wandering through the forest blindly on your own. Doesn't matter. Why? Just for the quiz?
Yeah.
Okay. You don't need anything. So put everything away except the writing utensil. Alright, since I was so kind to you, Serenity, I'm gonna make you be kind and hand that out for me. All your blue oxidation sheets you can put away. You need nothing but a writing utensil. Everything gets pulled away. That was your eraser, was it not, Serenity? Okay, you need nothing. Serenity, being the kind soul that she is, since I'm making noise for her, is handing you an oxidation sheet for the quiz. And we will collect these from you after the quiz. Tonight, are you waiting on an engraved invitation?
I'll do it some way.
Study it. You should already have those learned, babe. I have confidence in you. You've done what you need to do and know it.
So it's definitely
So what?
the formulas are going to be the
Maybe or maybe not. I might not put any on there. Or I might have. Like I said, I just pulled one out of my trusty notebook out of the back. I didn't even look. I just made sure it didn't have Covalent name on it. Because we haven't done that yet. The only thing I made sure of. All right, make sure your names and formulas are legible. Okay, I have to be able to read it. I think it was Serenity. Was it Serenity who was in here yesterday? I asked what a number was.
Yeah.
Yeah. She told me what she thought. It happened to be the wrong answer, and I marked it wrong. Okay, if nobody's here, you go with what I think it is. Just belly throw the sheet. Oh, but it should be pretty close. Pretty close.
Because I'm doing tell what we're doing.
Pretty close. Maybe they're still working. How about now? Everybody still working? Xavier, tell me when you're ready. Done? Didn't I just tell you to tell me when you were finished? All right, that's first in front. Yes, ma'am. All right, Serenity. Go fetch the oxidation sheets. You guys pass your oxidation sheets to the front for Serenity. Thank you, my dear. All right, let's start with those two up. Find your notes. Oxidation sheet. Again. The two people who got calculators, who put your calculators up on the end of the day. We might need them at some point on Monday. For sure, anyway. All right, so today, give Sinatra a title back there. We're still doing nomenclature, but today we're doing covalent compounds. Now, if you remember what I said the other day, I said that we could only use what system for ionic compounds? That was a little mumbling for me. I even turned the dehumidifier off. So ionic compounds can only use what? Stock system. Okay?
Which system is that?
Can somebody tell us? That's right.
Oh, okay, so it's the same thing.
It's the one we've been using. Okay, so just to make sure we're all together, how do you recognize if it's an ionic compound? Because if you notice down there on the board today, we may or may not get to it. But if we don't get to it today, it means it'll be first on tap for Monday. We're going to mix everything up. So how are you going to know whether it's an ionic compound and can only use stock, or if it's a covalent compound and it's going to be able to use both systems today?
Look if it's a metal or not. This is.
That's right. Stock, S-T-O-C-K system. All right, so you're going to have to figure out if it has a metal, it's automatically ionic. Okay? It is the first element. So all you have to do is look at the first element. And where did we say it had to be up here to be a metal? So what color is it? If it's in the blue, it's a metal. So if you have anything in the blue up here, it can only use the Roman numbers. Okay? So, when we go to write a formula, for example, for CaCl2, after we do our lesson today, some of y'all are going to want to use the prefixes. You're going to say, oh, that's a metal, no prefixes. Even though after I teach this today, some of y'all are going to be like, Swallow, why can't we use these prefixes? That's so much easier. I like the prefixes.
What do you mean prefix?
I'm getting ready to teach you how to do that in a little while.
Okay.
Now how you say carbon dioxide or sulfur trioxide, you don't have to figure out an oxidation number. You don't have to figure out if anybody's reduced. You just look at the subscript. If there's a 3, you call it a tri. If there's a subscript of 2, you make it a di. It's much easier. So we could call that calcium dichloride because there's two chlorines. We can't do that because there's a what at the front of that compound? A metal. So we can't use that system.
Is there never going to be like a metals in the second one?
No, not in first year.
Okay.
Never. Okay? So, since we're going to do covalent today, look, mouse, where did you go? There we are. All right. Since we're doing covalent today, covalent compounds use both stock, which is, of course, the Roman numbers. Now, the downside to the stock system is about 50% have been reduced. So that teaser that I gave you yesterday, I want to say it was Michaela who asked me this question, but I can't swear to it. All right, about an oxidation number that was on the chart and it went away somewhere in the formula and we had to figure out what it used to be. Okay, a lot of these compounds have been reduced and we need the original oxidation number. Okay, so you must find the original oxidation number. That's the downside to the stock system for covalent. When we did this prior to today, anionic compounds, maybe 5% has been reduced. So we don't run across a lot of that. And I'll be honest, I purposefully made sure that we didn't see a lot of that until we got to today. Okay, now I'll sprinkle in a couple. Now, the other system that you guys have to be able to use is you have to be able to use the prefix system, which we often refer to as old system. And you guys have had a lot of experience with in your other science classes like biology and earth science, because a lot of people still use this. Nobody calls carbon dioxide carbon-4 oxide in earth science or biology. That's its technical name, carbon-4 oxide, but everybody still calls it carbon dioxide, okay? So here, the thing people like about this is there are no oxidation numbers, okay? The subscript equals the prefix. That's the thing that makes the two systems different. All right, the stock system requires you to find the original oxidation number. The prefix or the old system does not require an oxidation number. We don't care what it is. The prefix is the subscript. That's the distinguishing factors between the two. Okay? Now, being able to go between the two systems is what drives chemistry students crazy. Now, if you can't keep them straight, okay? This is like when we did significant digit rules. Which one do you think you have to be able to use without fail? Stop. There are 2 questions on the test where I tell you you have to use old system. 2 is 4 points. Want to take a stab at how many points are in stock system?
A lot.
40 some. Okay? So if you can't keep it straight in your head, which one am I telling you not to be able to use?
Prefix.
Yep. Okay. Just making sure we understand which one's more important. All right, we're going to start with stock because that's the one we already know how to do. The rules are not different. We have no steps to write down. Okay? The only reason that we need to practice the stock system is because we need to figure out how to determine if something's been reduced. Okay? That's the part we need to master. All right? Okay, you must determine if the oxidation number / the subscripts have been reduced. That's really the only thing that's different. Everything else, the steps are identical. We're not doing anything different than what you just did on the quiz, what you did on the lab yesterday. So if you've mastered those steps, it's the only thing that's new. All right, we got it? Okay. Now, I'm going to use carbon dioxide because this one we're all familiar with. Okay? Now, oxygen is on your oxidation sheet, and this one you're going to memorize inside of today. But for right now, look up its oxidation number and tell me what it is. It's -2. Now, if its oxidation number is -2, all right, when we crisscross, where should this -2 be in the formula? Under the C. That 2 should be right here. Is the 2 right there?
No.
No. Okay? Because the 2 is not on the C, it was reduced. Okay? That's how you figure it out. You know oxygen's oxidation number is a 2. So when you crisscross, it should be where? It should be on the C. Does that make sense to everybody? Okay. If it's not there, it was reduced. That's the only way it can go away. We can't erase it. Can't make it disappear anyway by it was reduced. So you need the original formula. All right? So to find the original formula, all you have to do is multiply the 2 through, get rid of the extra T, the subscripts. All right. So, what is 2 times that 1? So C2, what's 2 times 2?
4.
So the original formula was C2O4. Now, the reason I multiplied by 2 is this is a what? That's what went away. It was supposed to be a 2 here, and the 2's not there, right? That's what I multiplied by 2. So, now I write the formula the way you've always written the formula. What's the name of the first element? What? So we write carbon. What's the name of O? We write oxide. I tell you a secret. Covalent compounds, every single one has a Roman number. Because when you look up the first element on your oxidation sheet, they all have many oxidation numbers. So when you look up carbon, it's going to say, I think, -2, +2, and +4. So, I know it has +2 and +4. So, what Roman number are we putting there? What number came from carbon? Questions? Zaya, you with me?
Yes.
Just dead for the day? Okay. All right, let's try another one. All right, so let's say that we have SO3. We want to write its name. Again, what is oxygen's oxidation number?
2.
2. All right. Is the 2 right there?
No.
Okay. There's no 2. What's that tell us?
It's been reduced.
It was reduced. Okay, so that means we need the original formula. All right, so what's the original formula? What do? Multiply the 2 through here. So what do we get? That's 206. So now when we write the formula, sulfur is oxide, and what number came from the sulfur?
6.
Now, to offer something different, all right, N2O4. Was this one reduced? I hear no. This one was not reduced. How do you know it was not reduced for those people who said no? The 2 is written. It's there. The 2 is in the formula. Okay? This one was not reduced. The 2 is in the formula. Okay? It's there. It's still part of the formula. So it was not reduced. So, how do we write this name? What's N? So we write nitrogen. What's O? Oxide. What Roman number? 4. Now, do I have to do all these with oxygen? No. I don't have to use oxygen. Everybody caught up? All right, let's say I have PCl5. What's P? Phosphorus. All right, what's Cl? Chlorine. What do you do to it? Chloride. Okay, so phosphorus chloride. Now, check out chlorine's oxidation number. What's chlorine's oxidation number? There's a lot.
-1.
Why is it -1, Allie?
Because it's second.
Because it's second, so it has to be negative. Good. So it's second, it has to be -1. All right. What number is supposed to be here?
1.
All right, it's a 1 right there. And there is a 1 right there. So if it's supposed to be a 1, and it is a 1, was it reduced?
No.
No. It's not reduced. Both are a 1. Okay? It's a 1 at the bottom. It's a 1 at the top. It's not reduced. So what Roman number are we going to put in there for phosphorus? A 5. The only time it's reduced is when you look here and here, and they're not what? They're not the same. So if we go back here to the first one I did, oops, too far. This was a 2, and this was a what? What is it if nothing's written? It's a 1. So if it's a 1 and that's a 2, are they the same? It was reduced. This was a 2 and this was a, are they the same? It was reduced. This was a 2 and this was a what? They're the same. Was it reduced? No, it wasn't reduced. So we didn't have to figure out the oxidation numbers. The formula was the same. Same thing here. They're both ones. It wasn't reduced. We don't have to figure it out. We don't have to go backwards and figure out any oxidation numbers. Does that make sense to anybody besides Ms. Wall? Okay. You got it? All right. I think I have type notes for the other, so you don't have to read my bad handwriting. Let's see. I think I do anyways. Might be under physical science. Yeah, there's also practice. Teach that with bonding. Yeah, that's it. Okay. Here we go. Old system naming. For those of you who like the title, old system naming. Yep, this is the old system naming. All right, so we're going to write the name of a compound in old system. So for Monica who likes titles, old system naming. Okay? Or prefix system, however you want to label it. Now again, I put this in bold because I do this in physical science. You can only do this for covalent compounds or two nonmetals. We cannot use this for a metal, even though some of you are going to try after today, even though I say this 400 times. People will still do it to me. Okay, step one. And there are only two steps. You name the first element. Add a prefix. And I use two words here that are key. Only add a prefix. And if, okay, there is a subscript other than 1. So are we always going to add a prefix?
No.
No, and that's the key. If the subscript is something other than 1, like it has a 2 or a 3 or a 4, we will add a prefix to that first element. But if it's just S and it has a 1, you just say sulfur. It does not get a prefix. But if it has S and it has a 2 on it, you're going to add a prefix. So you have to examine the subscript to decide if it's going to get a prefix. Okay? Does that make sense? So down here, I'm going to put in a little example. Let's go with orange. So, if you have SO2, how many S's is this? How many S's? I hear one little voice out there.
1.
Okay, that was a louder voice. What about the rest of y'all? Are you with me? How many sulfurs? There's 1. It's understood there's 1 if there's no prefix, right? So, no, or subscript rather. So there's no prefix on the sulfur when you write its name. Now, if you have something like the N2O4 that we have, how many N's are there? How many N's? 2. Okay, there was a few more voices, not many. You would have to include a prefix on the N. Okay, that's how you decide. You have to look at that first element and see what subscript it has. Because sulfur has a 1, sulfur's not going to get a prefix. But nitrogen has a 2, so nitrogen will have a prefix. Are you with me on that? Okay. We're going to talk about the prefixes in a minute, because I know y'all don't remember them all. Now, when you name the second element, you have to do 2 things. Okay? You must add a prefix. It doesn't matter if there's only 1. You must add a prefix. Okay? And then you do the standard add IDE. Okay? Most of us don't forget IDE at this point. At least I hope not. I haven't graded the quizzes, but I'm assuming that we can remember IDE at this point. But on the second element, you always add a prefix. It doesn't matter how many there are, it gets a prefix. The first one, you have to figure out whether you need it or not. The second one gets it regardless. Are you with me on that? Okay. Zai, did you have a rough night? Huh? Yeah. Stay up too late? All right. Anybody need more time?
Yeah.
Okay.
Wait.
All right, good? All right, so let's look at the prefixes. No, those are not prefixes. Those are not prefixes. Where are the prefixes? There are the prefixes, except I need to add 2 for y'all. Y'all don't need that. Y'all don't need that. All right, and you need Nuna equals 9 and Deca equals 10. Okay, those are your prefixes. Now, odds are good we will see a quiz on this Monday. I don't feel bad making you make sure you know all the prefixes by Monday, because with the exception of probably tetra, which you might have to learn, maybe nona and deca. You know all the rest of math class, for sure. Mono, you know. Di and tri, I know you know. Pentagon, hexagon, and octagon, you know. You might have to know 4 if you don't remember hepta is 7 because you learned poly and not hepta. Okay? So learning 4 prefixes is not going to overtax you between now and Monday.
Wait, so it's just only going to be on prefixes?
And then it'll be on naming covalent compounds. I won't mix it on Monday. Even I'm not that mean. It will strictly be on covalent.
Can I go stick my eye in the water fountain?
Stick your eye in the water fountain?
Yes.
I have an eye wash fountain if you want to see your whole face in it. But it might mess up your makeup if you want to make it.
I'm not wearing makeup.
Well, I didn't know.
You
You might have just put on mascara or something to make your eyelashes stand out.
No.
There's an eye wash fountain if you want to stick your whole face in
Why haven't
it.
you told me that before? I asked to go put my eye in the water fountain like a lot. It's normal.
Oh, well, there's an eye wash fountain. Stick your face in the eye wash
I'm kind
fountain.
of scared to use that, so I think
There's a lot of water flowing in your eyeball, but
yeah.
If you've got contacts, you might flush out your contacts, might have to fish them out of the drain.
Oh, that is.
All right, everybody got the prefixes. All right, so let's say that we want to write the name for this one. Okay? How many C's are there? So are we going to put a prefix on the C? No. So we're just going to write carbon. Now, I like to use this one because, believe it or not, 4 is the most missed prefix every year, every class. I have no idea why, but without fail, it happens every year. Okay? People say it's 3. People say it's 5. When I give them tetra, they get it wrong. When I give them the number, they give me the wrong prefix. I have no idea why. Okay? So, Br is what? Okay, so it's bromide. And we look at the subscript, and this is a 4. So we write tetra bromide.
Wait, why would we write?
Do we ever figure out what the oxidation number is for carbon or for bromine? Don't care what the oxidation numbers are.
Wouldn't there be a 1 next to the C? So why?
No. Remember, in the steps, you only put a prefix if there's more than 1. How many C's are there? 1. So there's no prefix on the C. Okay? We only put a prefix on the C if there's more than 1.
Oh, so it'd go before the
It'd go before the C.
Okay, that's what I was confused with.
We're getting ready to do one that's different.
All right.
Okay? But we don't care what carbon or bromine's oxidation number is. It's strictly about the subscripts. Yes.
Is it all one word?
There's a space between carbon and tetra. But tetra goes on bromide. All right. Everybody good? All right. So we're going to jump down to the bottom one. All right. N2O3. So this time, I have a number on the end. Again, I don't care what the oxidation numbers are. How many N's are in the question? So we're going to put a what on the end?
Di.
So di, nitrogen, and how many O's are there?
3.
So we say trioxide. And we're done. You see why people like this system better? You don't have to find the oxidation numbers, which is why people like this. Okay? You good? Now, we need to be able to work backwards with old system.
Oh.
It's easy. Now, to work backwards, oh, you dumb thing. There's the rule. All right, to write the formula from old system, that's all you need. There's the rules. There's the steps. The prefixes equal the subscripts. Okay? The prefixes are the subscripts. Now, I will write this up here because people will still try to do it. There is no crisscrossing. In old system. Okay? We're not crisscrossing an old system. So when we write the formula using old system, when they say like carbon tetrachloride or dinitrogen trioxide like we just wrote, they're giving you old system. You're not going to crisscross. The prefix is the subscript. Okay? So, hopefully I gave some different examples. Not going to do that one. We just did that one. We did all those. Let's do the bottom one. So sulfur hexafluoride, and then I'll make up a different one because we just did those two. All right, so sulfur hexafluoride. All right, so sulfur is S. Okay? there is no prefix there, right? So if there's no prefix, what does that tell you the subscript is?
1.
That means it's a 1. And I'm going to erase that in a second. I'm just emphasizing for teaching. All right, fluoride has what on it?
A 6.
That equals a 6. Okay? Questions about how the prefixes or the subscripts? We don't crisscross. Whatever prefix is on it is the subscript. Okay? So, if we have silicon, what's silicon? Okay, so Si. All right, the rest of y'all be quiet. Serenity was looking at me like I'm nuts. All right, so what's right here on silicon, Serenity? It's nothing, so it's a 1. All right, oxide is what? What's the symbol? Yeah, I know, but what's the symbol for oxide? What element is oxide? Yeah, so it's oxygen. Okay, and now what subscript are you putting on it? Yeah, that's all you're doing. You with me? All right, so diarsenic pentaoxide, Xavier. All right, what's arsenic? Use your periodic table. It's number 33.
8.
Okay. What does this tell you? So that means it's a 2. What's that?
Oh, I said that's
And how many does it tell you got? Y'all with me?
Yeah.
Yes? No? Maybe?
Yes.
Okay. It's not hard to do that, is it? Okay. The challenge is remembering when you see the prefixes not to crisscross, and when there's the stock system, you have to do what?
Crisscross.
Crisscross. The challenge is when I mix it.
No, my
Okay. Yes? No? You with me?
Yeah.
Okay. Now we're going to practice. Let me make this go away.
When are you gonna mix it?
You like those now.
Yeah, I'm going to let you know when it's mixed.
Jar no jar.
So what I got here. All right, that's not what I want. All right, let's start easy. Write me the formulas. Start easy. Write me the formulas. And then we'll write names in both systems. All right, we done?
No.
How about now? All right, so the first one. What you got? All right, so carbon has what prefix on it?
1.
So C has a 1 because it has no prefix right here. There's nothing. VR has a
4.
tetra because it's got.
We got right to one.
You do not have to write the 1. I'm only emphasizing for teaching purposes. I would not write the 1. I'm only emphasizing for teaching purposes.
Is it okay if you write the one?
It's fine if you write the 1. Okay, but because there's no prefix on carbon, carbon gets a 1. All right, tetra goes on the BR. All right, diphosphorus means phosphorus has a what?
2.
And oxide has a,
3.
okay. Iodine has a
1.
1. And oxide has a 2. Phosphorus has a, and chloride has a 5. And iodine has a,
1.
and fluoride has a.
7.
Questions? We got the hang of that? Okay. Now let me see what I want to keep and get rid of. Oops. Let's get rid of. Yeah. Why are you way out there, you dumb thing? Okay, it looks a little warped, but those. All right, write the names of those in both systems, okay? So if you want, go through and do them all in stock, and then go back and do them all in old. Or do them all in old system, and then go back and do them all in stock. If you're great with doing it in old and then stock, and do number 2 in old and stock, do it that way. Most people don't like to do it in both, and then go to number 2 and do it in both. But do whichever way you want.
Using both
Systems. So I want it in stock system and an old system.
Oh, so there's 2 answers.
There's 2 answers for every one.
Makes sense.
Because on the quiz Monday, 4 of them have to be in stock, 4 of them have to be in old, and 3 of them are what you just did with right before. And I choose which 4 are in stock and which 3 are in old. You don't get to choose. And if you have a question, just ask me. Just reading up on the news with Dorian. My sister's house currently is surrounded by a moat.
Oh my gosh.
Told her at least there's not a fire-breathing dragon there.
I'm dead.
My daughter said, well, if grandma could be there, it could be worse.
Oh my gosh.
See, some of y'all got that. She refused to go stay with my sister. She's like, oh, I'm fine at the house. If they flood though, she's stuck there because we can't get down the road either direction. So we hope she doesn't lose power. Or she'll be staying there at the house. Anybody got a question for me? Nah, you got one that you resting while I was teaching? Okay. What about you, Snoopy? I can see what you don't. Unless you don't. Anybody? Xavier, you got one? Yeah.
So, I can do this part.
Yeah.
Okay, then, stop me.
You have to use a Roman number based on oxidation numbers. So nitrogen, and that came from where?
Wait, this,
Mm-hmm.
then it be nitrogen, three, chloride.
Mm-hmm.
Okay.
Correct.
This one,
Yeah.
is there like three, do we have to find what it was before it was?
Correct. For stock system, yes. Clean. Well,
You said.
the Roman numeral one. So nitrogen chloride, and then you got to figure out what the oxidation number would be for nitrogen, and put in parentheses. So it's there. Yes. Correct. You else have a question? You done, Trevor? Yeah. Mm-hmm. You still write nitrogen and chloride, okay? And then you have to figure out what oxidation number came from in the formula. And then you make a Roman number. Okay, so what's chlorine's oxidation number? There's last.
Oh, one.
So it's gotta be a one. Okay, so it's a one, just not a one there. One right here. There's not a one that's there. So it's one, it is a one, so they're the same. So if these are the same, was it reduced?
No.
If they are the
Yeah,
same,
okay.
it was not reduced. Okay, so that means the three came from there. So what Roman number do you want to put there?
And
So nitrogen. Don't write, and you gotta write the word.
oh. Oh.
So nitrogen. Three, and then chloride. So like this one, all right, oxygen is a -2.
Yeah.
Yeah.
There has to be something.
So is there a 2 here?
This just has to let
Is
it.
there a 2 written right there?
No.
Okay, so since this is a 1, and that was a 2, these are not the same. So that tells you this one is 3. Yeah, I'm right upside down. Where you double check that there. You should get better at it. All right, and this one is reduced. So what it used to be, 2 times 1 is Okay, so that's 2, 2 times 3 is 6. Okay, so this would be named sulfur. What number came from the sulfur? Just on. Came from the sulfur. 6 came from the sulfur. Yes, so Roman numeral 6.
The B one?
And then, yeah. I like this one, but she's a whole lot skinnier than I am.
For number 4, is there something missing? There's not a 1 for the
Yeah.
oxidation number of.
Yeah, it's just not on the sheet. Those are the most common oxidation numbers, just not the only ones.
So.
It can be a 1 even though it's not on the sheet.
Okay, so, okay. Okay. So the oxidation number on, for this, I don't know, whatever.
So it can still be an oxidation number even if it's not on the sheet. So don't assume just because it's not on the sheet, it can't be that oxidation number.
Okay, so it, okay, so I should just write it as it is.
Yeah.
Okay.
Yeah.
I don't have to change anything. So we put nitrogen 1?
Yeah.
Okay.
Oh,
Wait.
So when you write, yes, this would be an example where you have to write the 1 because you're telling me what the oxidation number is. So you have to tell me it's a 1. This is not a place where it's an understood 1. Okay, so this is one of the rare exceptions where you have to write a 1. Yes. Yes.
Can you see if I did it right?
Yeah, right here. You're gonna go over the answers, but yeah.
I want to make sure. This one, that's number 4.
Okay, you put the prefix here. This one always has to have a prefix, so you gotta put a prefix there.
Oh,
monoxide. Yes, monoxide. All right, so number 1, let's do old system since most of you probably did old system. What would number 1 be in old system? Nitrogen trichloride. Number 2, nitrogen triiodide.
Would you put 2 eyes or just 1?
To who?
2 eyes.
Oh, typically we put 2 eyes. Okay. SO3,
Sulfur.
sulfur trioxide. 4,
Oh, I was gonna die.
dinitrogen monoxide. Even though it has no subscript, the second element always gets a prefix. Now, in that one, you see how you have 2 O's? We actually drop an O. Now, if you wrote 2 O's, I would not mark it wrong.
Wait,
But we actually drop an O on the monoxide. We don't put 2 O's so it looks like moose.
what is number 3?
Number 3 is 3 is sulfur trioxide.
Why?
There's 1 S, so sulfur.
I know, but I thought
There's
it
3
was
O's.
simplified.
Huh?
Like it was reduced.
We don't care if it's reduced in old
Oh.
system. That will be important in stock,
Okay, so
but we
you
don't
only
care in
want-
old system.
Okay.
Old system, the oxidation numbers are irrelevant. Thank you, Trevor.
Okay.
So number 4, it's dinitrogen monoxide, because you have to use a prefix on the second element. It has 2 O's, mono and oxide, we drop an O. Is everybody okay with what I'm saying there? We don't write it like moose. All right, N2O3 would be dinitrogen trioxide. Number 6 is silicon dioxide. It's got 2 O's. SiO2. So dioxide. All right, let's see what you've done on this next. Nitrogen 3 chloride. 2, nitrogen 3 iodide. 3, sulfur 6 oxide, it was reduced. 4, nitrogen 1 oxide. 5, nitrogen 3 oxide. And 6, silicon 4 oxide. If you didn't finish them all, it's fine. Let's talk homework real quick. Homework is the practice for Monday.
For the quiz?
For the quiz. All right, we're doing 2 through 12. 2 through 12, you're writing in both systems. So there should be 2 answers if I by chance check homework. I did not give you any to write the formulas because I'm sure you're doing okay with that. You're just writing the names of both systems in 2 through 12. Just 2 to 12. Okay, everybody got it? Got a sheet? 2 to 12. Both systems. And on Monday, we will begin to do what with the names?
Mix them up.
Mix them up. Because now we've done everything with naming, so we're ready to mix. Yes, you have a quiz Monday. And it will only be on Covalent. I will not mix on Monday. Just what we did today on Covalent.